All right, so let's really getting deep into these topics now for graphs of sinusoidal functions. So sinusoidal just means sine, cosine, those waves that we see everywhere. So the general form for sinusoidal functions, and again, sine and cosine are basically the same function, just shifted over a little bit. We'll call that a phase shift later on. General form for sinusoidal functions is y equals a times the sine of bx minus c plus d. And you can do another one with cosine if you want to, right? But it's basically the same thing. Just replace sine with cosine, and you have another definition. So in the next two videos, 812 and 813, we will talk about what each of these letters mean. But the short answer is that A is going to deal with something called amplitude. B has to do with the period. C relates to the phase shift. And D is going to eventually be a vertical shift. We'll talk about the first two in this video and the last two in the next one. And if you remember function transformations from pre-calc 1, if you remember function transformations, that's all these are, right? A is multiplying on the outside of the function. That's a vertical stretch. D is being added to the outside of the function. That's a vertical shift. B is being multiplied on the inside. That's a horizontal stretching or compressing. And then C is subtraction on the inside. That's going to be a horizontal shift. So that's all these are right here. We'll talk about them a little bit more in depth, but let's start with the first one, amplitude. So let's kind of visualize this real quick using Desmos. So A is the amplitude. A is the number in front of sine. So let's just look at this real quick. And let's zoom out a little bit, right? Let's go from negative 4 pi or negative 4 pi up to pi or something. All right, here's sine. What happens if I put 2 here? Oh, well, now it's twice as tall. 3 times as tall, etc. You get the idea. This is just how tall is the graph. It's that vertical stretch. The amplitude is how far above the middle do we go and how far below the middle do we go. So the middle, which we'll talk about later as a midline, the middle is 0. So the amplitude is 3 means we go 3 up from the middle to get to the max and 3 down from the middle to get to the minimum. Okay, so that's where we're going to start right here. So the amplitude is the greatest distance from rest. We'll talk more about that in a minute, but let's also mention the period while we're here. Remember that the period of normal untransformed sine is 2 pi. Well, the period, and again, period is just how long does it take until things repeat. So let's kind of combine those topics to give you a good definition of the period. For y is equal to sine of x or cosine of x, the period is 2 pi, which means that every 2 pi units, things repeat. Right here is the same spot on the graph as over here. Or we could look at that from a different perspective, right? Here is the same part as here. Wait, I'm trying to show something that my camera's blocking. Here is the same part of the graph as here. What's the difference between these x values? Do the math and you'll get 2 pi. Just make sure that you are not comparing these 2 points, because these are not the same portion on the graph, even though the y value is the same, right? These are the same parts of the graph. They're the same y value, and they have the exact same shape. Okay. So the period of a regular sinusoidal function, untransformed, is 2 pi. And then b, this b value down here, up here, has to do with how fast we're going. So look at this graph. What if I double how fast we're going? Put a b value of 2 here. It goes twice as fast. It oscillates twice as quickly. The frequency doubles. So how long does it take to repeat now? Half as long. So now it repeats every pi units because we made it go twice as fast. If we made it go 4 times as fast, the same thing would happen. If we made it go half as fast, now it's going much more slowly, which means it takes twice as long, 4 pi now, twice as long to repeat itself. So b, you can think about b as like the speeding factor. Okay. The period is 2 pi, and then b speeds it up by that much. Or slows it down. Right, so b equals 2, it's twice as fast. So if we put that all together, the period will be 2 pi divided by the magnitude of b, because b could be negative too. So we want to take the absolute value and turn b positive. Also, while we're giving these definitions, right, the amplitude is just exactly a. I have something red on my finger. I don't think it's blood. It might be a red pen. The mystery. What is it? All right, so that's the amplitude. Amplitude is exactly a. Period is 2 pi divided by b because of this reason right here. Okay, because b slows it down. So it starts with 2 pi, but if we're going twice as fast, if b is 2, then it's going to be half as long. All right, so that's going to be our period. Let's do some examples here. Example 2. Find the period for f of x equals the sine of pi over 6x. So we could graph this and find it graphically, or let's find it analytically. Our b value, right? B is pi over 6. So if we know the period is always 2 pi divided by the absolute value of b, that's going to be 2 pi divided by the absolute value of pi over 6. Pi over 6 is positive. We don't need these absolute values because it's already positive. Well, we have a complex fraction. 2 pi divided by pi over 6 is 2 pi times the reciprocal. And we can write 2 pi as itself divided by 1. Multiply these fractions. These pi's are going to cancel. And 6 times 2 is 12. The period is now 12 units long. So we're making it pi faster and 6 slower. Pi shorter, which is 2 now, and then 6 longer. 2 times 6 is 12. Period should be 12. Let's graph it. Let's see if we're right. Sine of pi over 6. Right, the sine pi over 6 times x should have a period of 12. And so you might say, it's hard to see. You can click on this to see it, or we can change our step size. Now you can see, okay, yeah, it's repeating every 12 units. Pick 2 points that are on the same part of the graph, and the distance between these x coordinates, -9 and 3, should be 12, has a period of 12, which is actually pretty close to 2 pi. No, it's not. It's about double 2 pi. All right. So let's go back to amplitude again a little bit, do an example. I mentioned the amplitude is the greatest distance from rest. Rest we can think about as what's known as a midline. So if I have a graph of a sine graph or a cosine graph, the midline is kind of what it sounds like. Okay, so let's look at the midline real quick. Midline is the graph y equals d, and that d is the vertical transformation. It's this d right here. Okay, so if I'm looking at a function, maybe like y equals sine of x plus 2, the midline should be the line y equals 2. Because that's our d value here. And it's the equation of a line. This is very important, right? An equation of a line is always in the form y equals or x equals. So don't just write 2 here. It should be an actual equation. You need this. So watch out for this. Let's look at this graphically. We're looking at sine of x plus 2. The midline is the graph y equals 2. So you can see that, yes, this midline is just the horizontal line that goes through the middle of the sine graph. So the amplitude is just, well, how far above do we go and how far below we go? Well, look at the y value. How far above is 3? It's 1 above. How far below is 1? It's 1 below. That kind of ties these topics together. Let's do example 3. Find the amplitude, which was a, remember, and the midline for the following. F of x equals -4 sine of x. All right, I just realized that the amplitude is not exactly a. Amplitude is the absolute value of a. Because amplitude is distance, it can't be negative. A very small thing, but it's worth fixing. So in this case, right, what is our a value? Our a value is -4. What's our d value? There's no d here. You can think about it as +0 if you want. D is equal to 0. So a is -4. D is equal to 0. And that gives us all the information we need. The amplitude is the absolute value. It's 4. The midline is the line y equals d. This is our amplitude. Man, now I want fast food, right in red and yellow next to each other. Let's check our answers. -4 sine of x. -4 sine of x. Oh, we have to change our scale. Let's go from -5 to +5. And let's go from -4 pi to +4 pi and split it up with pi over 2 again. And why is this step not actually doing a step of pi over 4? Oh, that's bizarre. Oh well, so our midline should be y equals 0. Yep, that looks right. That's our midline. Our amplitude should be 4. From the midline, we go 4 up to get to the top. From the midline, we go 4 down to get to the bottom. We're good to go. Part B is going to be g of x equals 1/2 cosine of x plus 1/2. So again, the amplitude is just the absolute value of a. The midline is just y equals d. The amplitude here is 1/2. The midline is y equals d. Y equals 1/2. So one is a value and one is a line. Watch out for that distinction. Let's check our answers. Let's look at 1/2 cosine. Whoa, cosine, tab out of the fraction. 1/2 cosine of x plus 1/2 is this graph right here. We say our midline is 1/2. Good. That is the middle of the graph. And let's zoom in a little bit on the y-axis. What's the distance between the midline 1/2 and the top of the graph? This vertical distance is a distance of 1/2. What's the vertical distance here? 1/2 as well. So the amplitude is indeed 1/2. We're good to go. That's our answer, and that's this video. Let me know if you have any questions, and good luck.